Hello everyone. Today we are going to solve a problem on measures of variability in terms of mean deviation, standard deviation in both grouped and ungrouped data. And we are going to discuss the merits and demerits of mean deviation and standard deviation. Now let us look in brief about the mean deviation and standard deviation. The formula for mean deviation in terms of grouped data is sigma sigma xi minus x bar by n, and for grouped data it is sigma fi into xi minus x bar by n. Here x bar is given by sigma xi by n and n is given by sigma fi. For standard deviation in ungrouped data, it is given by root over sigma xi minus x bar whole square by n, and for grouped data it is sigma is equal to root over sigma fi into xi minus x bar whole square by sigma fi. Here also x bar is given by sigma xi by n and n is equal to sigma fi. Now let us see problem for standard deviation and mean deviation for both grouped and ungrouped data. First of all, let's see for ungrouped data. Here the problem is find the mean deviation and standard deviation for the following data. And the data elements are 57, 64, 43, 67, 49, 59, 44, 47, 61, 59. And the number of elements are 10. Now let's solve the problem. This problem we have to find mean deviation and standard deviation. Here we are going to calculate mean deviation and standard deviation based on mean. That means with respect to mean. As it is not mentioned in the question, by defaultly we will calculate mean deviation and standard deviation with respect to mean. Here to calculate the mean, the formula is x bar is equal to sigma xi by n. And to calculate sigma xi, we are going to add all the given data values, and it is equal to 550. And n value is 10 as the number of elements are 10. Therefore x bar is equal to sigma xi by n, that is 550 by 10, that is equal to 55. As we have calculated the mean, now we are going to calculate mean deviation. The formula for mean deviation is sigma xi minus x bar by n. Here we all know n and x bar we calculated. Now we have to calculate xi minus x bar. X bar is 55 and xi is the corresponding data element. Here xi minus x bar is 57 minus 55, that is 2. 64 minus 55, 9. 43 minus 55 minus 12. And similarly we will calculate all these values. Now we have to calculate the modulus of xi minus x bar. Then we will get 2, 9, 12, 12, 6, 4, 11, 8, 6, 4. And by adding all these values we will get sigma xi minus x bar, and that is equal to 74. Now the formula for mean deviation is sigma xi minus x bar by n, that is equal to 74 by 10, we get 7.4. This is the mean deviation for the given data. And now we have to calculate standard deviation. To calculate the standard deviation in ungrouped data, the formula is root over sigma xi minus x bar whole square by n. We all calculated sigma xi minus x bar, and now we are doing square of it, that is equal to 481, 12 square 144, 12 square 144, 6 square 36, and similarly all these are calculated. Now we are going to add and we will get sigma xi minus x bar whole square, that is equal to 662. And next, by plugging the values in the formula, we will get root over 662 by 10, that is equal to 8.13634. This is the standard deviation for the given data. We have calculated the mean deviation and standard deviation for ungrouped data. Now let's see example for grouped data. The question given in grouped data is find the mean deviation and standard deviation of the following data. It is grouped data. In grouped data, we all will have class intervals and frequencies. And we have 5 class intervals here and their corresponding frequencies. Now let's see the solution. In this problem, we are going to calculate the mean deviation and standard deviation for the following group data. Similar in from the ungrouped data, we need to calculate mean in order to calculate mean deviation and standard deviation, as we are calculating mean deviation and standard deviation with respect to mean. To calculate the mean, the formula is x bar is equal to sigma fi xi by sigma fi. Here xi is the mid value of the class intervals, and we find the xi as 0 plus 4 by 2, that is average of them, that is 2, and for this interval it is 4 plus 8 by 2, that is 6, and for this it is 10, 14 and 18. We all calculated the xi, and next we have to calculate fi xi. Fi xi is the product of fi frequency and the xi we find before, that is 4 2 is 8, 6 6 36, 8 and 8 5 14 70, 2 8 is 6 36. And now we will calculate the sigma fi xi, that is equal to 230, and in the denominator we have sigma fi. Sigma fi is the sum of the all frequencies, that is 25. To calculate the mean is 230 by 25, that is 9.2. The we found the x bar value, that is 9.2. Now next we have to find mean deviation and standard deviation. In grouped data, the formula for mean deviation is sigma fi into xi minus x bar by n. Here we found the value of x bar and n is sigma fi, that is 25, and we know the value of fi and xi. So we have to compute the terms individually. Now xi minus x bar is equal to, here xi is 2 and x bar is 9.2. Modulus of xi minus x bar is 7.2, and for this it is 3.2, 0.8, 4.8 and 8.8. Now we have to multiply it with fi, as in the numerator we have fi into xi minus x bar. Now to find this term, we are multiplying fi and modulus of xi minus x bar. We get 28.8, 19.2, 6.4, 24 and 7.6. And by adding all this, we get sigma fi into xi minus x bar, that is 96. So by substituting the values in the mean deviation, we will get the mean deviation for the following data. It is 96 by 25, that is equal to 3.84. It is the mean deviation. Now let's find the standard deviation. To find standard deviation, we have to find the value of xi into xi minus x bar whole square and fi sigma fi into xi minus x bar whole square. To find the numerator value, first we have to square the value of xi minus x bar, that is 51.84, 10.24, 0.64, 23.04, 77.44, and we have to multiply it with the given frequency, corresponding frequencies. By multiplying, we get this fi into xi minus x bar whole square, and by adding all this we get sigma fi into xi minus x bar whole square, and the value is equal to 544. Now by substituting the values in the formula of standard deviation, that is sigma fi into xi minus x bar whole square by n, we get root over 544 by 25, that is equal to 4.66476. Here we can round the values to our required wish. And we have seen the examples in both cases, that is group and ungroup. Now let us see the benefits and disadvantages of mean deviation and standard deviation. Firstly, merits and demerits of mean deviation. First, merits. It is simple to understand. As we know, we have seen mean deviation is easier to calculate than the standard deviation, and it is easy to calculate. It is based on all observations. We have considered all the observations. It is not very much affected by extreme values, and it has practical usefulness in field of business and commerce. And coming to demerits, it is not rapidly defined in the sense that it is computed from many of the central values. The central values are mean, median, and mode. It is not defined rapidly and produces different results for different types of calculations. And it violates the algebraic principle by ignoring plus and minus as we have considered modulus, and it is not capable of further algebraic treatment. It is not affected by fluctuations in sample, and it is not suitable for sociological studies. And now discussing about the merits and demerits of standard deviation. Merits and demerits of standard deviation. Firstly, merits. It is rapidly defined and free from any ambiguity. It is based on all observations. We have considered all the observations. It is strictly follows algebraic signs. We did not consider any modulus operators, but we considered, but as we are squaring, it only takes positive values. So negative values are not affected. It is capable of further algebraic treatment, and it is used as a formidable instrument in making higher statistical analysis. And coming to demerits, it is not understood by common man. That means a person without some knowledge in statistics, there are many calculations, and its calculation is difficult as it involves many mathematical masses and models. It is affected very much by extreme values of a series in as much as the squares of deviations of the big items proportionately bigger than squares of smaller items. And it cannot be used for comparing the dispersion of two or more series in different units. These are the merits and demerits of standard deviation. And finally, by concluding, today we have completed the mean deviation, standard deviation. Thanks.